Hello, greetings to every one of you and welcome to this video. Today I am going to be teaching the topic functions in mathematics, preparing you for the concours that's ahead of you, the customs concours douanier Cameroonese. So in this video, I am going to be giving you the details under the topic functions in mathematics. I am going to be giving you what you need to know as far as function is concerned for the concours that you are going in for. Before I start, I would like to wish you all good luck as you prepare to go in for this concours, that you're going to understand what I am about to teach, and in turn you're going to remember them by the time you get into the examination hall, and that's going to give you a success. Right away, we're going to begin with the topic function. To begin with, we shall start by defining. In my big one, we shall be looking at the definition of a function. The definition of a function. Just as simple as that, a function is defined as a function of a variable. I believe before now we have treated a topic known as algebra, and so you know what a variable is. A function is a mathematical equation which can change depending on its value. For example, we can have a function f of x. When you see f of x, it simply means that it is a function of x. So the function varies, or the equation I am about to give you varies with respect to x. F of x can be equal to 2x plus 3. For example, it's just an example. Now, you notice that whatever the value of x may be, the function changes its value. We are going to see this by the time we are going to be evaluating functions. We can also have a function like g of x, 3x minus 2 over 5x squared, something like that. G of x is a function. G is a function defined by x. We can have functions like u of x equal to something, v of y equal to 3y plus 2 over 3y minus 1, for example. These are functions. Now, after knowing what a function is and how a function can be represented, we are going to now look at how to find the domain of a function. That's the next important thing that we are going to be doing. To begin with, I would like you to know something. The domain of a function. We are about to treat the topic, the domain, the subtopic, the domain of a function. This is to the effect that each function has a domain of definition. The domain of definition of a function are the values that the function can take. In simple parlance, the domain of a function is defined as the range of values for which the function exists. The range of values for which the function is valid. The range of values for which the function is defined. So now, I'm going to take, for example, the function of x, f of x, to be equal to 3x plus 2. Now, when I am asking myself, what is the domain of this function, I am indirectly thinking that what are the values of x for which this function is valid, for which this function is existing, for which this function can have a value. What are the various values of x for which this function exists? That the set of those values give me the domain of definition of the function f of x denoted. This is how we denote the domain of the function. The function f, the domain is df, the domain of f. Now, remember we are taking this as an example. You are going to realize that no matter the value of x you put in here, it is going to bring out a value because it's a linear function. This is an example of a linear function. And all linear functions are defined on a set of real numbers. This represents real numbers. So the domain of f is such that x is a real number. Any real number will satisfy this situation. So this is how we can write a domain. The domain is such that x is an element of the set of real numbers. Any linear function, for example, let's say h of x equal to 3x minus 2 is also linear. V of x equal to 5 plus 2x. It is also linear. When I say linear, what does it mean? It does not have a power. It is not a fraction. It is not a logarithmic function. It is linear. And all linear functions are defined on a set of real numbers. That is the first thing we need to know about a domain. So the domain of a linear function is defined on a set of real numbers, and this is how we write it. Alternatively, I can say that the domain of a function like this one is equal to, I give the bounds from negative infinity, this means infinity to positive infinity. And what does it mean? It means, in fact, this is the representation of a set of real numbers. In mathematics, a set of real numbers is equal to all numbers from negative infinity to positive infinity. What is the meaning of infinity? Infinity is an imagination of a very large number. So we consider infinity to be the biggest number. Remember that when we want to take a bound, we are looking at where it may start to where it can end. But now, the set of numbers is an infinite set. And this is therefore to the effect that the set of numbers never ends. The set of numbers do not have an end. And because of that, we cannot have in mind the biggest number. Or if you know one, let me know in the comment section. The biggest number. Some people will tell you that it's 500 million, but then there is 600 million that is bigger than that. You tell me that it's 5 billion, but 10 billion is also bigger than that. You tell me that, and so there is the biggest number is imaginary. The set of number never ends. It continues till infinity, meaning that it continues to a certain imaginary biggest number. So in mathematics, we consider that biggest number to be called infinity, and it is represented by this infinity. Now, we also consider on a set of real numbers, we have both the positive and the negative numbers. So on a set of real numbers, the biggest positive number is positive infinity, and the biggest negative number, otherwise known as the smallest number, is negative infinity. And all of them are represented on the set of real numbers. Therefore, the domain of a function If it is defined on R, it simply means that it takes all the values between negative infinity and positive infinity. This can include any number like negative 25, 42, any number like 53, any number is a member of this set, including 0. Now, I am presenting this to you because you may have MCQs, multiple choice questions, among which this could be the correct answer. So you should not just know how to write a domain, maybe like this or like this, but you should also have in mind that what this actually means. However, this is it for the domain of a linear function, and I hope you understand what a linear function is and what the domain of a function is. If I can repeat myself, I will be saying that the domain of a function, it refers to the set of values for which the function exists. And when a function is existing, how do you know that a function exists? A function exists if the evaluation of that function gives a value, even if it is 0 to any value. For example, we are going to take the function f of x equal to 3x plus 2, for example. If x is 2, the function will exist. If x is negative 10, the function will exist. If x is 20, the function will exist. And we are going to see this when evaluating functions. Now, we are also going to look at the domain of a rational function. Now let us consider, let f of x to be a function like 5x plus 2 over x minus 2. We need to find the domain of f. Now, this is no longer a linear function. When you look at this, it has now become a fraction. You can see a numerator, you can see a denominator. Now the domain changes. The way you can determine the domain of this kind of function is different from what I just explained to you about linear functions. Here, what do we do? I would like you to know that any number, in fact, just note that any number divided by 0 is equal to what? Is undefined. This, if you can take your calculator and punch any number like 500, 2, 3, any number divided by 0, you will have your answer as math error or syntax error because it is undefined. It does not exist. So, this therefore tells you that for this function to exist, the denominator should not be 0. Because if the denominator is 0, the function is undefined. Therefore now, the denominator should not be 0. Means that what? I don't care about the numerator. No matter what is the numerator, it will still cause the function to exist. But this should not be 0. If this denominator is equal to 0, the function is undefined. Good. So that is the first thing you should know as calculating or looking for the domain of such a function that exists like a fraction. The domain is such that the denominator should not be 0. So now, how to find the domain? The first thing, you let the denominator to be equal to 0. This is it. X minus 2 equal to 0. Any common person with a normal brain will know that if x minus 2 is equal to 0, then x is equal to 2. How do we do that? We flip this to the right hand side of the equation and we have that x. Now, if you don't know, I will tell you that when you cross a number from the left hand side to the right hand side of the equal sign, let me put it in color. This is equal to here. When any number crosses this equal sign, the sign of that number will change. So what we're going to do is that x, this is minus 2, and we want to send minus 2 to this side of the equation, and x will be equal to what? The sign changes to plus 2, which is the same as just 2. Because when we did integers, I told you that when your number is positive, you must not put the sign. Plus 2 and 2, they are the same. But minus 2 and 2, they are different. When you see just a number without a sign, it means the sign is positive. If you don't know how to do this, comment section, I'll explain more. So now, it means that for x minus 2 to be equal to 0, x should be equal to 2. Now, it means that if your x is equal to 2, the denominator will be 0, because 2 minus 2 will be 0. And when the denominator will be 0, the function will be undefined. So now, given the domain of the function, it means that this function can take all values except 2. This function can take all values except 2. How do I represent it? The domain is such that x is an element of the set of real numbers except 2. Look at what I've done. X is an element of the set of real numbers except 2, because when x is 2, the function will be undefined. Also, I can just represent the domain by saying that x should be different from 2. I've not done any different. It's still the same thing like this. X should not be equal to 2. That's the domain of this function. Also, the domain can be represented by the bounds from negative infinity to 2. Union from 2 to positive infinity. Yes, this is another way of representing the domain. Meaning that x can take all values between negative infinity and 2, but it cannot take 2. And after 2, it can take numbers again from 2 right up to positive infinity. Only 2 is excluded. I believe you have been able to understand at least. I may take another small example. Let g of x be equal to 5x squared plus 2x over 3 minus x. You notice that they type this kind of equation, the function is still the same like this, because it's a fraction, it has a denominator, and so for it to be to exist or to be valid, the denominator should not be equal to 0. Yes, and so to have the domain, we have to put the denominator 3 minus x equal to 0. And if we do this, the same thing we did on the other side, we are going to have that if 3 minus x is equal to 0, then x is equal to 3. Meaning that when x is equal to 3, this function is undefined. So the domain of the function g will be the set of real numbers minus 3, meaning the set of real numbers except 3. Or I can say x is an element of the set of real numbers except 3. Or I represent it as such with 3 here. Good. So that is it for the domain of this kind of functions. There is still another one we are going to look at. As far as the domain of a function is concerned, we are going to look at the square root function. We are going to look at the limit function, natural logarithm. Let's go. Now, let f of x to be equal to the square root of x. Yes. The domain of this function, df, the domain of f, should simply be such that this function, this x here, x should be greater than or equal to 0. What's the meaning of this? It means that x must be bigger than or equal to 0, meaning that x can only be from 0 upward. X cannot take negative value. In other words, x must be positive. Why? The square root of a negative number does not exist. So if x is negative 4, the square root of negative 4 does not exist. Otherwise, it's a complex number. So, for the square root of a number to exist, that number must be positive. Take note of that. The number must be positive for its square root to exist. Now, and that's the representation. The representation, x must be bigger than or equal to 0. So it's simple. This is the domain for this one. This is the domain, just like that. Just like that. X greater than or equal to 0. Or someone could still put that x is an element of the set of real numbers, but x greater than or equal to 0. It's still the same thing, alright? This is the most common way of just writing the domain of such a function. Now, let the function h of x be equal to the square root of 4x. Yes. Now, the domain of this function should be such that this 4x should be greater than or equal to 0. Then you divide both sides by 4. Reason being that this 4 will cancel with this 4, so that you should have x. I hope you can do this at least. So x must be greater than or equal to 0. This is the domain. This is the domain. Now the last example I'll take, let u of x equal to the square root of 3 minus 2x. Yes. Or simply 3 minus x, for example. Yes, 3 minus x. The domain of u should be such that this 3 minus x should be greater than or equal to 0. So now, for 3 minus x to be greater than or equal to 0, is simply, so from here, if 3 minus x should be greater than or equal to 0, then it simply means that x should be less than or equal to 3. This is the domain of the function. The domain of u is such that x should be less than or equal to 3. Notice that the sign has changed. If you don't know how to evaluate inequality and you don't know why the sign has changed, let me explain. This is 3 minus x greater than or equal to 0. So what I can do is I can take this negative x to the right hand side, and it becomes 3 greater than or equal to x. And if 3 is greater than or equal to x, it means that x is less than or equal to 3. So that is this is the easiest way you can have this. By the time we treat inequality, I will explain more on how to come out with to solve inequalities like these ones. Now the last type of function whose domain we can determine. I'm about to give the lane. Now, let f of x be equal to ln x. The only thing I want you to know here is that the ln of a negative number, negative 3 for example, is undefined. It does not exist. The ln of a negative number does not exist. Meaning there's no log of the logarithm of a negative number does not exist. So by the time we put ln, we must always try to put an absolute value, and the absolute value means that what? That no matter the value here, it should be positive. It must be positive. Yes. Okay. So the domain of this function is such that x should be what? Positive, greater than or equal to 0. Simple. The same way we did for the square root. So if we have f of x equal to ln 3x minus 1, then the domain of f will be such that 3x minus 1 should be greater than or equal to 0. Then we solve it the normal way. And then we are going to have that 3x should be greater than or equal to 1, x greater than or equal to 1/3. Okay. Now what about if we have a function like h of x equal to e to the power x? X here is defined on the set of real numbers. Any real number goes. This e to the power, for example, we have v of x equal to e to the power 2x. It's all the same. Any value, the domain here is on the set of real numbers. X element of the set of real numbers. So that is it for the domain of a function. We are done with the domain of a function. Let us look at how to evaluate a function. Evaluating a function. I'll still use some of these examples to explain to you how we can evaluate a function. Okay, let f of x be equal to 3x minus 2. Find f of 2. This is what I mean. Here, you just notice that x has been replaced here by 2. So simply you put 2 anywhere you see x here. Then you are going to have is going to be equal to 3. X is replaced by what? 2 minus 2. 3 times 2 is 6 minus 2, 4. As simple as that. Let g of x be equal to 3x minus, no, not 3x again, x squared minus 2x over 3x minus 1, for example. Find g of 1 or find g of 3. G of 3 will be equal to, I put 3 in the place of x. Use a 3, I'll put it in. in different color. Good. 3 squared minus 2x, which is 3, over 3x. X here is 2. X here is 3 minus 1. Now 3 squared is 3 times 3, which is 9. Minus 2 times 3 is 6. 3 times 3, 9 minus 1, 8. 9 minus 6, 3 over 8. This is your answer. So this is how we can evaluate a function. We simply substitute that value in the function. You can also find, for example, let's take this. We'll find f of negative 2. It will be equal to 3 negative 2 minus 2. Simple. 3 times negative 2 is negative 6 minus 2 negative 8. That is it. Now we are going to look at how to calculate composite functions, meaning a function of a function. Now we are talking about composite function, and I'm using this as an example. Let f of x be equal to 3x minus 2 and g of x equal to 2x plus 1. Find gf of x. Gf of x can also be represented by gov. Sometimes you can see by gov, g of f. So it's the same thing. Now gf of x simply means, now this is g of x, but I need to replace f of x the way we did when evaluating function. I need to replace this f of x in the place of x wherever there's x in g of x. So now g of x is 2x plus 1. So g f of x will now be what? 2. Now in the place of x, I'll put f of x, then plus 1. Simple. So this will be 2. F of x is 3x minus 2, then plus 1. I evaluate this. 3 times 2 is 6x minus 2 times 2 is 4 plus 1. 6x minus 4 plus 1 is minus 3. This is it. Now, I'll also find the function for or f g of x. Here now, I'll simply go to the function f of x, which is defined by 3x minus 2, and then I'll put g of x there. So it will be 3, in the place of x, I'll put g of x minus 2. Now, g of x is 2x plus 1, then minus 2, which is 6x. 3 times 2 is 6x, 3 times 1 is 3, minus 2. Now 6x plus 3 minus 2 is plus 1. This is it for f g of x, otherwise 4. Anyhow, it could be represented. That is it for composite function. Any question? Comment section. The last part of function we are going to do this morning is the inverse of a function. There are 3 steps. The inverse of a function, let f of x be equal to 3x minus 2. Let f of x be this. The inverse of this function is denoted f inverse of x. And there are 3 steps. So let's find f inverse of x. Find f inverse of x. Step 1. I repeat, step 1, let y to be equal to the function that I've given you. So the first thing I'll do is let y to be equal to f of x. This simply means that y is equal to what? F of x. F of x is 3x minus 2. That's the first step. Step 2, calculate x. Now, I'll do my own gymnastics towards x. But I'll first of all say 2 here. I'll have that y. 2 has come here to become positive 2. I already explained. Plus 2 equal to 3x. I'll divide both sides by 3. 3 will cancel here. I'll have that x is equal to what? Y plus 2 over 3. Step 3. Replace x. Replace y here with x and x here with the inverse. So f inverse of x is equal to what? I replace here with x plus 2 over 3. That's all. I've succeeded to calculate the inverse of the function. Simple like that. Just simple. Another one. Let g of x be equal to x plus 2 over 3. Find g inverse of x. Step 1. Let y equal to g of x. This simply means that y will be x plus 2 over 3. That's the first step. Step 2. I calculate x. How? Y here means y over 1 equal to x plus 2 over 3. Cross multiply. I'll cross multiply. 3 times y is 3y. Will be equal to 1 times x plus 2 is x plus 2. Now I can send 2 here. Let me indicate it to you. I'm going to have that 3y, the 2 come and the sign change become minus 2 is equal to x. Simple. So it simply means that what? X is equal to 3y minus 2. Now, the third step is to do what? I replace here the inverse. So I have that f working with the function g. G inverse of x will be equal to 3x minus 2. Ladies and gentlemen, we have been able to go through the first thing, the definition of a function. Second thing, the domain of definition of a function. Third thing, examination or evaluation of a function, how to calculate a function at a given point or at a given value of x. Next, we have been able to look at composite function or a function of a function. And finally, we have been able to determine the inverse of function. So I believe that as far as function is concerned, you are well armed for the exam that is ahead of you. Again, I wish you good luck. Thank you for watching. Thank you for understanding. And good luck as you continue to prepare intensively. I am Sir Godwill Yako.